Hey, good afternoon. I'm Mark here from J-Tech again, and I'm here today to kind of give you a basic layout of a relay that we're using that most cars use. They're called ISO relays, which is industry standard relay. That's pretty much what ISO stands for. And both of these relays that I got laid out here today, one is showing the actual operation, how it looks inside the relay when it's operating. And this is what you would see if you pulled a relay out. And this relay that I've got here happens to be this relay here that is actually out of a Ford, who knows what. These relays are pretty much universal, but I do know this particular unit is a Ford relay. But I wanted to show you guys today the basic operation of a relay. Okay, you're going to see several devices or several pins here that I've shown, and they pretty much correlate to the pins that you see on how the basic relay is laid out. Okay, I'm going to pull you just a little closer. Okay, there we go. All right, so we have 86 here first, which is this pin here. Okay, and we have 85, which is this pin here. These two pins are actually the coil within the relay that pulls the contacts together or pushes them together, as this would be. As you'll note, we have 85, 86, 87 alpha, 87, and 30. On pretty much any relay in the industry today, 30 is always going to be battery power. So you're always going to have source voltage on pin 30. Okay, and it comes over, and as you can see, this is the actual switch, and as you can see, it's tied into 87 alpha, which is not used. 87 alpha can be used, but in most instances, the center pin, which is right here, is not used. 87 alpha. All right, you could use this if you wanted to, say on a fan or something that had a timer on it. If you wanted to shut the engine off and this drops down, this thing would kick on, say, an alternate fan to run for maybe 30 seconds, 45 seconds to cool your vehicle down, or whatever the case may be. Or you could use it for some other particular instance, but there's numerous things that you can do with these relays. Okay, so what happens is this coil is roughly 74 ohms. It might be a little more than that, but this is basically a 74 ohm relay. All right, and what will happen is you can see 85 goes directly to ground. That's pretty much what it is. Now this ground could be through the steering column up to the horn button. So this could actually be a horn button if you really wanted to, and the horn button would be the ground. As a general rule of thumb in the automotive industry, grounds are always the controlling side of a relay. You have to make a ground or put a load on, or put a low on it in order to make the relay operate. Okay, you'll note that 86 is actually tied to the ignition. Okay, and that could be anything. That could be a coil. It could be your fuel pump. It could be anything. But this comes directly from the ignition, and of course it'll have a fuse of some sort in line with this particular line, because if you have and same with 80 or same with 30 would also have a fuse in line with it for whatever amperage it pulls. Okay, when you activate and turn the ignition on and this relay is activated, it actually swings up and connects these two contacts together, which 87 then would go out to the device. The device could be your air conditioner, it could be your fan, it could be numerous things, your windows, power windows, power door locks, power seats, anything can be controlled by this relay. Pretty much 100% of the stuff in automotive industry today, it works with relays, unlike it was back in the 40s, 50s, and 60s, where they were actually running high amperage wires through the dash up to the steering column to your ignition switch. So just to kind of give you an idea, this is what we're doing with this, is just to show you. And this particular drawing over here would show you how these pins are laid out. 87 would be here. So this one here would be your, what I call load. And a load could be to a device of some sort. Okay, 85 again would be your ground. 86 over here would be ignition. 30 would be battery positive. 87A is normally not connected. So that's pretty much the relay on how it lays out. These relays, they're very hardy. They work and work and work, and if you ever have an open or something, if you got a relay that isn't working, you can literally take this hard relay that I got here in front of you. This is the actual relay, and if you take this relay out, you can literally start troubleshooting 4 separate lines going to different items to see what your issue happens to be with the, is it in the relay, is it in a wire come to the relay. There's numerous things you can do. You can connect here, you can connect, or connect here, and connect here. By simply pulling the relay, this would allow you to use, you can check for a good ground, you can check to make sure the ignition is actually giving you voltage, you can check the load, and you can actually power that to the load, or you can do a resistance check to see if you've got something broke or to that end. And then a 30, of course, you can check it to see if you actually have a fuse that may be blown or something to that effect that's affecting the power coming to, or power that's going to be used on the device. So in a nutshell, these two are one and the same, but this kind of shows you how this relay works. It comes up and down just like that. Activated, it'll push it up or pull it down depending on how it's wired. But for the most part, that's kind of how the relays are laid out. This is how they operate, and I hope this has been of use to you folks, and it'll give you a good idea where to start the next time if you have something where a relay's not picking up or maybe a relay's stuck, that type of deal. So thank you for watching, and appreciate it, and we will see you again, I'm sure.